The intent of this video is going to be to help you find inverse functions when they involve logarithms or exponential functions. Now we've already sort of talked about, if you've studied exponential functions already and the basics of logarithms, you may have talked about how to convert an equation either from a logarithmic equation, log base 3 of x equal to something like 27, where you can take the swirl method and you can start at the 3 and kind of swirl your way around, and you'll end up with an exponential function saying 3 to the 27th power would equal x. This also works very nicely when you have an exponential function, something like e to the x equals m. Well, if we start at the base and kind of work our way around to the exponent, then the log base e, also called the natural log, of m, so that's now inside of your function, would be equal to your exponent, the x. And you found a way to solve for the exponent. Well, if given a logarithmic equation, you want to find its inverse. Remember, you're trying to convert back and forth. Logarithms and exponentials are inverses. Logs and exponentials are inverses of one another. So if you're given problems such as find the inverse of y equals log base 9 of x, or y equals the natural log of x minus 2, or this log base 5 equation down here at the right, one easy way to do that is to convert those to an exponential function. Remember that in order to find an inverse of a logarithm, we want an exponential. One way you can do that is using the swirl method that we just talked about. Another method would be exponentiating. And so we'll probably show you that both ways. So over here, we'll show the swirl method. Over here, I can show you that exponentiate is another method. It's basically a little bit more mathematical. It's sort of canceling away the function. So the swirl method, first of all, would say, well, y equals log base 9 of x. So let's start at the 9. We'll start at our base. So that's going to be the base of our exponential. And we're going to raise it to, right, do that swirl and sort of raise it to the other side of the equal sign. Now, in order to find an inverse function, however, we don't want to be solved for y, or sorry, for x, we want to be solved for y. So the first thing we probably should have done, remember that anytime you're finding an inverse, step 1 is always switch x and y. So I'm going to go back over here, and from our original equation, right, we're going to switch x and y. So I'm going to take my x and I'm going to put it on the other side of the equal sign. I'm going to take my y and I'm going to put it inside the logarithm. So that now when we do the swirl, it becomes 9 to the power of x equals y. And we are back again, solved for y. And we actually have the inverse function of our original. Log base 9 of x and 9 to the power of x, exponential base 9, would be inverse functions. Another way to do that, again, is to switch x and y as step 1. We want to make an inverse. So we're going to first call this x equals log base 9 of y. Then we can exponentiate. In order to cancel a logarithm, we can use an exponential. Remember that 9 to the power and log base 9 are inverse functions of one another. So if I take 9 to the power of both sides, on the left I get 9 to the x, just like we did over here. And on the right side of my equation, 9 to the power of and log base 9 are basically going to cancel each other out. And we're left with just y. And notice that's exactly the same equation, y equals 9 to the power of x, that we had on the left. So switch x and y, then attempt to solve for y. See if you can solve the two equations down here at the bottom. Feel free to use either the swirl method or the exponentiating method. Alright, hopefully you paused your video for a second so that you gave yourself time to do this. But if not, try it now. I'm going to go ahead and start solving away here. So first step, remember, to finding an inverse is to solve or switch x and y. So I'm going to call this x equals the natural log of y minus 2. Then I can say, well, let's do that swirl method. Let's start with the base, which remember for a natural log would be base e. So I'm going to start there and I'm going to swirl my way around. So e to the power of x equals y minus 2, what used to be inside the logarithm. And then second step, I just need to add that 2 over to the other side. So in order to get y by itself, solve for y, I'm going to say e to the power of x, and then outside of my exponent, I'm adding a 2. Notice we're now solved for y. Over here at the right, let's go ahead and do the exponentiating method. Now, first thing again you want to do is switch x and y. So x equals log base 5 of y plus 12. Now notice that plus 12 is outside the logarithm, so we need to get rid of that before we worry about the log. So let's go ahead and subtract our 12 on both sides. X minus 12 will equal log base 5 of y. And then in order to get rid of that log base 5, we can exponentiate 5 to the power of both sides. So the y that you're left with over here at the right will be equal to 5 to the power of x minus 12, all up in the exponent, and there is your inverse. Now, one quick thing we can do with inverses is that it actually helps us graph exponential functions and logarithmic functions by hand. If I want to graph a log base 2, it's helpful to think about its inverse. Remember that exponential functions were easy to graph if we used easy points. So we can think about what are the easiest things or what are the nice numbers to plug in for an exponent. And two of the easiest things to plug in are 0 and 1. Negative 1 also isn't bad to think about, or we could think about larger numbers. But again, the two major ones that we wanted to use are definitely going to be 0 and 1. So I'm going to shade those in. They're more important than the rest. But if we think about it, 2 to the 0 power is 1, and 2 to the first power is 2. Those are two very easy to find numbers. Again, 2 squared would have been 4, and 2 to the negative 1 is a half. Remember, negative numbers make fractional numbers. Right? Negative exponents make fractional numbers. But again, those two simpler numbers in the middle are probably easier to use. We also want to remember that exponentials have an infinite domain. However, the range was always limited by a horizontal asymptote. It always had a line y equals 0 for a basic exponential. That would change if we were shifted up or down. But y equals 0 for a basic asymptote, and the range was that y is always greater than, not or equal to, just greater than that number. So, when we think about our logarithm, one hint is that they're inverses. It's going to be the inverse. Log base 2 of x is the inverse of 2 to the x. So all I really need to do is take all of my x's and y's and switch them. Where x would have been a half, my y value will now be negative 1. Or where x was 1, y is 0. Where x was used to be 1, now the y is 1. Where y was 2, x is 2. So I'm just flipping all of these points around. If x is 4, the log base 2 of 4 equals 2. Again, the asymptote also switches. Instead of being horizontal, it's now vertical, because instead of being y equals, will now be x equals. And where the domain used to be all real numbers, that's now the range. Where the range used to be y is greater than, it's now going to be x is greater than 0. So to graph our exponential function, we'll graph that in blue. Y equals 2 to the x. I'm just going to plot the two easiest points, 0, 1, and 1, 2, with a horizontal asymptote at y equals 0. So I got a little bit low there. It serves the purpose. We're going to coast over, run through our 2 points, and go up, realizing that we're counting by ones in each direction here. Now if I want to graph the logarithm, same idea. I'm going to grab the two easiest points, the two in the middle, 1, 0, and 2, 1. And I'm just noticing that we were off a little bit. If you notice on that blue graph, I was off a little bit on my point up here. So I'm going to get rid of that. Kind of had the feeling I might mess that up. 1, 2, a little bit lower here. Coast upwards just like that. And now go back and I will put on the log function. Again, 1, 0, 2, 1 with a vertical asymptote at x equals 0. So I can follow that asymptote, hit the 2 points, and then coast my way out to the right. And technically I should hit 4, 2 up here. Having some trouble graphing. Realize we're going to hit that point up there and coast out that way. Much like we should have hit 2, 4 on the blue line there, close enough. Now realize they should look very similar to one another because again, any inverse function is a reflection over the line y equals x. So they should look like perfect reflections over those lines. Now there is an easier way to graph, and you may want to find a video graphing inverses or graphing logarithms using easy points, because that'll actually help you graph directly on the logarithm rather than having to find its inverse, plot the points, flip the points over, and do all the extra work. But this is still a very good method, so I hope that helps you know how to find inverses and one good use for them. Good luck on your homework.